Recorded. All right, hi everybody. So today is August 28th. You know tomorrow is the convocation, right? The schedule changes, and we all meet for meeting. Bless you at 11, right? And there'll be free T-shirts and box lunch. Yes, tomorrow. Yeah. And when is our first quiz?
This Friday.
This Friday. So yeah, the quiz will be available in Blackboards after the midnight. Then you have one day, 24 hours to start the quiz. And once you start the quiz, you submit your quiz within 30 minutes. Okay, everybody? And have you been start working on your homework?
Yes.
Yes. Are you questions?
So wait, can you take the quiz anytime?
Yeah, any time of that day.
So we don't have to take it in class?
We don't take it in class.
Oh.
When is it after the time?
The 11:59 p.m. Yes. So it starts from midnight 12 a.m. and then you until the whole day until 11:59 p.m. I suggest you start your quiz before 11:30. So you have a half an hour to work on your quiz.
30 minutes long?
Yeah, 30 minutes long.
About how many questions?
Two. Usually two questions.
Wait, what?
On your quiz, two questions. Usually, if it's in class, then you should just take 15 minutes to finish your quiz. But I make it online, so I give you time, extra time, to take pictures, and then email yourself, and then convert it to PDF, and then upload it in Blackboard. That's why I give you 30 minutes. In theory, it should only take 15 minutes. Mm-hmm. Yes. And remember, it's better to use your laptop to open the quiz, because if you use your phone to take pictures, and I'm afraid you get locked out, then you have. So I set the unlimited attempt. So if you have locked out for the first attempt, you start a second attempt right away, and then submit the quiz. Okay? But if you use more than one attempt, you have to email me and tell me why. Maybe your internet is not stable. Maybe you have to tell me a reason. Okay? Email me. So that is the quiz. And are you all able to go to your homework and submit? So remember your homework, you have unlimited attempts. And so yeah, you can submit your first attempt, and then I give you sample solution. Do you remember? I gave you sample solution. So it's on our course website. So your homework. Yes, so this is linked to all homework sample solution. So I hope your first attempt, you just do it on your own. And then your second attempt, you can look at the solution and try to see what you did wrong and then to fix it. Okay, everybody? That's your homework. So you can redo your homework multiple times until you get the perfect scores. Okay, if you have questions, feel free to come to ask me. Okay, so any questions before we continue? And yeah, today we continue to talk about session 1.3. So for sure Wednesday, we're going to talk about 1.4. How many of you get your hand out 1.4? Okay, not everybody. So other students, do you know how to print out your worksheets? Do you know? Okay, let me remind you. So yeah, for the rest of the semester, you need to print out the worksheet before coming to class. So this is week 2. So 1.3 is still the same as 1.1 and 1.2. So it's the same handout. And then 1.4 and 1.5 is another worksheet. So you click this, you can see the blank note. And so you can download this blank note, and then you go to printing.indianatech.edu. And you log in, and then you can click web print, submit a job. And then that library over there, the library printer is here, ACC library color printer.
The downstairs one?
So this is 1.1, you already have that. So you print at 1.4.
Oh, the downstairs one that's in black and white is the ACC 105.
Oh, ACC 105 is black and white. Okay? And it's cheaper. Oh, but can you change the settings so it's print black and white?
I haven't printed off that one.
Ah, okay. Yeah. So black and white is 10 cents each page. color is 50 cents each page. Yeah.
So since these are like the notes, that were like these are notes that when we show you at the end of the year, we get extra.
Oh, yes.
So
You can write on your board.
I could just show you the
Sure.
whole list. It's actually easier for me.
Yeah. So feel free. If you have your laptop and you take tablets, you want to take notes on it, feel free to do that. Then you can save paper. yes, you can do that too. Right. Okay. Any questions? So yeah, Wednesday. Yeah, please have your worksheet 1.4 ready. Because you see the worksheet has a lot of things. I strongly recommend you to print out the worksheet. Then you don't need to spend all the time to copy all the graph and copy all the questions, right? And it can help us use our class time more efficient. We can save some time to good work or any activities. Okay. So last time we talked about a function is increasing if f of x2 is greater than f of x1 when x2 is greater than x1. So the picture is like this. You're going up from left to right. That's increasing. Decreasing is you're going down from left to right. You're going down, decreasing. Constant if the y remains the same, right? Constant. And then f of c is the relative maximum or local maximum if f of c is greater or equal to f of x for x near it. So you can draw the picture. This is like the mountain. This is the highest point, right? And similarly, relative minimum or local minimum, you draw the picture. So this point is the lowest point, right near it. So this is the relative minimum. And then last time we saw this picture, right, we cut it into pieces. Here, decreasing. And here, increasing. Decrease, increase, decrease, and increase. Right, everybody? And I said you just need to put parentheses. Don't need to put bracket. Don't need to include the endpoint when you say whether it's increasing or decreasing on some intervals. Okay, now next, let's find relative maximum and minimum values and the x value at which each occurs. Okay, let's from the left to the right. Look at this picture. Ooh, what's this? Relative minimum. Yes. So we can put relative maximum. So okay, relative maximum and relative minimum. And we know this is relative minimum. What is this point? -1, -3. Yes. So -1 and -3. Okay? So -3 is the y value. We usually call this as the relative minimum value. Okay? And we say this relative minimum occurs when x equals -1. Okay? So the minimum occur at, so we can say occur, okay. This relative minimum occurs at x equals -1. So this is what it means. The y coordinate is called the relative minimum value. It has a value, so the y value. And then it occurs at x equals -1. But you can put a point here that it has all the information. It has the relative minimum value and it also has the x coordinates. Okay, let's keep going. Okay, roller coaster, right? So and then go. Ooh, what do you say this point? Yes. And what is the coordinate?
37.
Yeah, 37. So relative maximum 37. So now we know 7 is the relative maximum value. Okay, and the relative maximum occurs at x equals to 3. Am I? I guess so. Let's confirm that. Yes, we are. Thank you. Yes. Doesn't hurt to remind me more. Thank you. Okay, good. So we're right here. My alarm. Attendance. Okay, good. So the attendance sheet. So yeah, I print out a new attendance sheet because we have like more students enrolled in this course. So yes. So start your initial. Okay. Thank you. All right. So we're here, and then we go. Oh, what's this point?
6.2.
6.2, and it's a relative minimum. Okay, 6.2. All right. And then what happened here?
7.3 at max.
Yeah, 7.3 relative maximum. So far, so good, everybody?
Yes.
Okay, and look at this. Is this a relative minimum? Yes. Is it the smallest point? Yes, it is. What's the coordinate? 9.1. So 9.1 is a relative minimum. Okay, everybody? Let me draw more picture. Okay, so if we have something like this, do we have relative minimum? No, because this point is empty circle. The point is removed, right? We don't include this endpoint, therefore we don't have relative minimum. Okay, so here, no relative minimum. Yeah, this point we have because this point is smaller than this side and then this side too, right? Even though here, this point is the smallest point on the right hand side, but on the left, we have more points lower than this. So this is not a relative minimum. Okay, everybody? All right. And similarly, if you have something like this, we don't have relative minimum, right? Because that point is missing. Okay, good. All right, now it's your turn. Do example 1. Okay, find the domain and range. Domain and range. And check with your neighbors. Oh, it's okay. Good. You can just do it right now. Thank you. You know, on our website, we have those with answers.
Yeah. Using it.
Okay. It's pretty nice. You can watch the recording.
Wait, you do the lowest number first?
Yeah, let's. The domain, so it's just how, where,
Right now,
between what.
oh, okay. Thank you.
Oh, okay. But
Yeah, you're not
open
looking.
is like parentheses.
Yeah.
Okay.
That's good.
Hello.
So it's open circle.
You want to have interviews.
This is one.
Yeah, that's the range. So then you can make them equal to.
So how do you know?
Well, it said it doesn't have to.
But if this one was this one, Yes.
Chat with your neighbors to see if you have the same answer. Okay, so are you talking about the domain? It's just domain, right? Domain for up to 3, 4 yourself. You don't include it here. Yes, do you see the range? So you think about imagine the shadows. You switch on the y-axis, which is that this line is 120. So it's a set of 3 lines. So to indicate points, you use rays.
So you go all the way to the end.
Okay, so because it's a single point, this is a single. So if you want to indicate a single point, you can use set notation. So the set notation, and then and for implementing this principle, because we never reach function. If I don't want to so the main is check down on the x-axis. Let's go over let's look at the answers together. Okay, so to find the domain, right? Our sun is like here, and you want to look at the shadow, so you project everything on the x-axis. And let's look at this point. Do you see we get the point -4? Yes? And then imagine the shadow up to here, right? And this point we get a open circle because this point is missing. Okay? So domain, project on the x-axis, look at the shadow. So our x is starting from the left-hand side, negative number, the right-hand side, positive number. Do you see the -4? Do we include -4?
Yes.
Yes. So bracket -4 up to what? 4. parentheses. Very good. Do you all get that, everybody? Okay. Range. Let's use green for range. So range, now the sun is right here. We want to project on the y-axis. So this point we project down and then here, right, everybody? And you project down. Oh, okay. So our shadow is up to, do you see our shadow is up to the 2? And this piece also projects on here. Okay, so also project down here. But it's okay. Actually, with this piece or not, it doesn't change our range, right? You just have more stuff, but you share the same shadow, right? Okay, so our shadow is from -3 to 2, and we include both endpoints, right, everybody? So range is -3 to 2 brackets. Right, everybody? Okay, part B, domain. So domain, project on the x-axis. Do you see this arrow? It means go up forever, right? So you can, when you project down, okay, it's gonna be, so project down on the x-axis, it's gonna be everything here. See this open circle, still open circle. Can you imagine the shadow is from -infinity to 2, right? So -infinity, parentheses, because we never reach the infinity or -infinity. We're just approaching it, but we never reach that. So always parentheses with infinity. And then 2, do we include the 2? No, so parentheses. Yes. So far, so good? Yes? Okay. Now, range. Range. Project on the y-axis. So you see, okay, project on the y-axis. Okay, the lowest point, I would say the lowest point is the 1, right? Can you see the lowest point? It's 1. And then you just go up, see? You just go here, and this go here, and then you just all have your shadow from 1 to infinity. Right, everybody? So range is from 1 to infinity. Okay, good. Last picture, domain. Okay, from the left to the right. So -3 open circle. And do you see this point get project here? So even though this point is missing, but we get this point project here. So the point is not missing, right? Just keep going until here. Here, do you see this point also project down here? So no point is missing. So it's from -3 up to 4, right? So -3 up to 4. No points missing. That is the domain. And then the range. When you project on the y-axis, do you see when you project on the y-axis, this piece, you just get a single point 1, right? This piece, you get a single point 0. This piece, you get a single point -2. So you actually get 3 points. So -2, 0, and 1. So to indicate a point, I mean just a number, use set notation. So -2, 0, and 1. So this is the set notation. So we cannot use interval, right? We have to use set because it's an isolated point, right? Okay. So that's the domain and range. Any questions about that? All good? All right. Yes. Okay. Now, please continue to work on example 2. So look at this graph and answer the following. Determine intervals on which the function is increasing and decreasing. And find all relative maximum and minimum values. And also the x-ray curve. Oh, this point is open, so this point is. And you put parentheses to indicate. You cannot have a small number on the wall. Okay. Do you see the arrow? That means it actually go further. So minus infinity up to, yes.
So. How does it do?
Like here.
So it's here.
You see? Oh, okay. So more than that.
So 0
So increasing and decreasing. So look at this piece, it's decreasing. So then you write it down minus infinity up to -1 is decreasing. And then from -3 to 3 is decreasing. Sorry, -1 to 3 is decreasing. So write that here. And then here to here, 6 to 7 is increasing. Sorry, 3 to 6 is decreasing. 6 to 7 is decreasing. 7 to 9 decreasing. 9 to infinity increasing. So this exercise is similar to that. Oh, so you need the notes. Yes. Yeah, arrow works.
So you always start from the hardest one? Yeah. So there.
That's this one?
Yeah. That's the first one. Yeah, you already went down. Now you're back. Because you're only so you're doing
Yeah. Yeah, because it's easy. Okay, so don't forget. Always use pen because it's kind of it's the one answer. Because increasing decreasing the whole
there'll be time. Yeah.
So to make things simple,
Only count.
So it's only counting next round.
Yeah.
So
You're
this
not
would be
doing
easy, but not really.
Yeah.
it goes down. So no relative number.
No, it's regular numbers. This is going this way. Only
Find the, yeah, you can write it like this, or you can just say x equals to -4 to.
So now.
So I do like.
Here, basically it's 0. This point is 0.
That's the first one.
Oh, yeah, this is 0.
Yeah. Is this one doesn't have?
You look, when you say decreasing or increasing, you're talking about the x side. So that's why this point,
No,
the
it's
x side is minus. And this point, the x side is 0. So it's decreasing from minus 1 to 0.
Yeah. That's it. For example,
So there's two minimum.
No, for increasing and decreasing, you're looking for on the interval. Because a single point doesn't really tell you anything. Right? So
okay, yeah.
just always put parentheses. Yeah, yeah.
Okay.
Because a single point, you cannot say increasing or decreasing. You have to have more than one point that you can
Yeah,
see.
yeah, that's right, yeah.
Oh.
Alright, let's check our answers together. Okay. So we have increasing and decreasing. Let's use this symbol. Okay, look at this piece. What do you say? Decreasing, and it's from negative infinity to negative 2. So negative infinity to negative 2. Okay, next, here, what do you say? Increasing is from negative 2 to negative 1, increasing. And then here to here, negative 1 to 0, and it's decreasing. And then here to here, increasing. 0 to 3, yes, good. And last one, what do you say?
3
to infinity, and it's decreasing. And you just need to put parentheses when they ask you intervals of increasing and decreasing. Because the end point doesn't really make a difference. Because a single point, you cannot tell whether it's increasing or decreasing. So it's actually a whole interval, the trend. You need more than one point to tell, right? Okay. And then part B, find the relative maximum or minimum. Okay, let's look at from the left to the right. What do you say at this point? Negative 2, 0, and it's a relative. Yeah. So relative max and relative minimum is at negative 2, 0. Yes. See, part A, you're answering intervals. Part B, you're answering points. Even though it still looks like parentheses with two numbers, but they have different meanings. Interval and point. Okay, everybody? Okay, how about here? Do we have a relative max? No. You see this point is missing? So we cannot find a point that is the highest point among all the x nearest. So no relative maximum. And here, this is a relative minimum. And 0, negative 2. So 0, negative 2. Okay. You see the order really matters. X coordinate and Y coordinates. Okay? Yeah. It's just this graph it happens, but other graph maybe. Yep. Doesn't matter. For the whole problem you can change the order. But within the order pair, yeah, of course X and Y. Yeah. Okay, how about here?
Maximum 3.
Yeah, maximum 3, 3. Okay. Oh, that's it. Right, everybody? Okay, part C. Find the values of x such that f of x is 2. So your y coordinate is 2. Okay, can you tell me the x?
So it's 2, 2, and 2, 4.
And yes. So you look at the x, you get negative 4 and 2 and 4. Right? So negative 4, 2, and 4. So we have 3 values of x. So far, so good, everybody? Yeah, yes. Right, right. So here and here and here. We have 3 numbers. And sometimes maybe my graph didn't draw long enough, but you can make it longer. Let's say if I want to find x value such that f of x equals to 3, then what do? Okay, you get this point of 3, right? Then you also need to keep going. Maybe you have a point here. Oh, what is this point?
-5.
-5, yes. You can make the graph longer. Okay, everybody? So don't just answer 3. No, more than that. You have 3 and -5.
So you want us to do that on test then?
Yes, if the graph is not long enough, then you have to make it longer, right? Because arrow, so some graphs you see an arrow, but some graph maybe I don't draw an arrow. If I don't, even though I don't draw an arrow, that means it will keep going. If I want you to stop there, I will put a solid point. Okay, everybody? So no matter an arrow or not, it just means keep going. Okay? If I want you to stop there, I will put a solid point. It depends on the software when I draw it. Okay, some software when I draw it, there's no arrow. Is that clear, everybody? Okay, yes. Good. All right. Yeah, okay. All right. Let's keep going. Okay, average rate of change of a function. Okay. So have you learned physics in high school? You learn about distance, time, and speed, right? So if you drive 100 miles in 2 hours, what is your average speed? So what is speed? Distance over time. Bless you. Distance is 100 miles and the time is 2 hours. What's that? 50 miles per hour. Right? How many of you have driver license? Okay. Okay, so you know how to calculate your speed? Right. Okay, so 50 miles per hour. Okay. All right. Let's keep going. So this is the picture. We have the time, it's the horizontal axis, hours, minutes. And then we have the distance, it's the vertical axis. And then the average speed is like the slope of the seek line. Can you see, everybody? So average speed is the change of the distance over the change of time. So you get the slope. So average rate of change of a function f of x between x is a and x is b equals to the slope of the seeking line passing through it. Okay? And remember, slope is change of y over change of x. Yes. Did you learn slope before? Slope.
Yeah.
Yes. Okay, so we can also say this is the slope. Is the change of y, this is change of y over change of x. And because you have 2 points, this point is a f of a, and this point is b f of b. So change of y is f of b minus f of a. And then change in x is b minus a. Is that okay, everybody? Mm-hmm. Yes. So note the average rate of change can be thought of the sum of the seeking line passing through those 2 points. Okay, so have the picture in mind. All right, example 5. Find the average rate of change of this function between x equals to -2 and x equals 0. Okay. So we can put average rate of change. So average rate of change is the change of y over change of x. Change of y, because we're looking at those 2 points, right? So you can put f of the final point, 0, minus f of the initial point, -2. Is that okay, everybody? So f of the second point minus f of the first point. And then the denominator, b minus a. So the second point is 0 minus the first point is -2. So you can do that. By the way, if you change the order, it's okay. But you have to make sure you change the order for both the numerator and the denominator. Right, everybody? So you can use, okay, here I use f of the second point minus f of the first point. And here second point minus the first point. Or you can use f of the first point minus f of the second point, with the denominator first point minus the second point. You must make sure these order match. Okay, so this is the same point, this is the same point. Okay, let's see, what is that? So, what is f of 0? Look at this. F of 0, what's f of 0? 1. Yeah, 1. You plug in x is 0. So 1 minus 3 times 0 squared is 1 minus 0 is 1. Right, everybody? What is f of -2? Oh, let's do it slowly. 1 minus...
That's not how he works.
1 minus 3 times we plug in x is -2, right? Square. Okay. So we plug in x is -2. And don't forget what? What do you say this? Parentheses. Your baby. Okay? Don't forget your baby in the mall. So go shopping. Oh, but don't forget your baby. Alright. So here, what's -2 squared? 4. 4 times 3, 12. Yes, 1 minus 12 is -11. Did you say -11?
Yeah.
Okay, yes. Good. Okay. So now we are ready to plug in. F of 0 is 1. And f of -2 is -11. Okay, everybody? We have parentheses, -11. Right? How about denominator? 0, what's minus -2? Plus 2, yes. Oh, how about the numerator? It become 1 plus 11, right? What's 1 plus 11? Yeah, 12/2 is 6. Very good. So this is the average rate of change of the function between -2 and 0. So far, so good, everybody? Okay. All right. Note the average rate of change on the interval a to x is the difference function. You cannot have the left endpoint is a, your right endpoint is x, right? So difference of quotient, you have f of the endpoint minus f of the initial point over endpoint minus 3. Okay, so difference of quotient. If you switch the order, you must switch the order for both numerator and denominator. Right? You can do that. Why? Because when you switch the order, it kind of have the minus sign in front of it. Right? Do you know that? When you switch the order, you have a minus sign in front of it. And when you switch the order, you have a minus sign in front of it. Is that okay, everybody? That's why all your minus sign cancel. So you get, f of a minus f of x over a minus x. So, yeah, order does not matter, but you have to match them. Okay? So, either first point minus second point, or both second point minus first point. Right? You cannot have f of x minus f of a and then about a minus x. No, they have to match. Yes. Where? Here? Before the equation? Here?
The middle one.
The middle is equal? And, negative. I cancel the negative. No, because when we switch them, we get a minus sign, right?
Why is that? Okay, think about it. F of x minus f of a. You think of this as minus negative f of x and minus f of a. You can put a minus negative here. And then you can factor out the minus. You get negative f of x plus f of a. So that's why it's negative f of a minus f of x.
So if you switch the order, you get a minus sign in front of it. Right, everybody?
Mm-hmm. So, yeah.
And the average rate of change of f of x on the interval from x to x plus h is the difference quotient f of the final point minus f of the initial point over the final point minus the initial point. Okay, everybody? And these two, you use them in calculus 1. How many of you need to take calculus 1? Yes. So, okay.
So you might learn that in calculus 1. Okay. Yeah, so calculus 1, we'll talk about differentiation and integration.
So to define derivative, we actually need this. I can tell you more. So what's derivative? Well, you have a function f, right? Derivative actually represents the slope of the tangent line. Yes. So f prime of x is the slope of the tangent line at the points. Okay? So what do is you can consider the secant line. Now you look at 2 points. Let's say this is x and the second point is a. And then you let the a getting close to it. So you see, you have a lot of secant line and it converts to the tangent line. So you use the limits and the difference of quotient. This one,
All the other ones?
you will learn that in calculus 1. So it's the secant line. Use the secant line to approximate the tangent line. So this is the theory in the future. Okay, that's why
We need to know an average rate of change. Okay. Practice. Determine the average rate of change of the function shown below between the indicated points on the graph.
write it down. It's the difference of y and over the difference of x. What's the y coordinate of those points? Oh, okay. So you can say average rate of change equals to the y over x. Oh, okay. Then you can look at the. Okay, how about you label your first one? What's the first one? What's the x? S is the one. Yes, maybe 2 and 2. That's the first one. How about the second? Yes. So it will be change of y over change of x. So use the y coordinate of this point minus the y coordinate of this point over the x coordinate of this point minus the x coordinate. Okay.
It's just the slope of this.
Not quite. Okay. So usually you do the f of the second point minus f of the first point. And when you talk about the first point and second point, you talk about the x points. So here.
Okay, so let's go over all together. So here you have, look at the first point. What's the coordinates? The x coordinates, -2 and 2. And then this point, x coordinate is 1 and negative 1. So average rate of change equals change of y over change of x. Right, everybody? Okay, let me use different notation. So you can use f of your second point minus f of your first point over your second point minus your first point. Right, everybody? Or you can use the notation, okay, y2 minus y1 over x2 minus x1. It all means the same thing, right? And now look at your picture. This is x1, y1, and this is x2, y2. So what is your y2? Negative 1. Minus, see? Y2 minus y1. What is your y1? 2. And your x2 is 1 minus your minus x1, negative 2. Yes, everybody? Mm-hmm. And actually, this means f of 1 is negative 1, right? Because y equals f of x. So here, negative 1 is f of 1, right? And then here, f of negative 2 is what? 2. So this is the y coordinate, this is the x coordinate. Y equals f of x. Okay? So that's why if you want to use this notation, you're saying f of 1 minus f of negative 2. And f of 1 is negative 1. And f of negative 2 is 2. Okay? So that you don't put f of minus 1. Actually, f of minus 1 will give you this one. Right? So be careful. Alright. Minus 1 minus 2 is what? Negative 3. Minus 1 minus negative 2? Yeah, very good. So the answer is negative 1. Let's look at the slope. Do you see it go rise 1 unit and go down 1 unit? Exactly negative 1 the slope. Yes, right? So we go to the right 1 unit and go down 1 unit, so the slope is 1. Okay. If the slope is negative 3 over 4, what does that mean? See? Right, over 1. So down 3 and go to the right 4 units. Right? So you have a point. Go down 3, 1, 2, 3, and go to the right 4 units. 1, 2, 3, 4. Boom. And so on. So sorry, here. Okay, so this is the line of slope. Okay, everybody? Mm-hmm. Good. All right. Find the average rate of change of the following function on the interval 0 to h. Simplify it. And let's start with an easier problem. Okay, let's call this part B. Okay, part A. Find the average rate of change on the interval 2 to 5. Do this first. Okay, do part A first. Let's work with numbers first, and then let's work with variables. Okay.
What's that? Yeah, yeah, the first one.
Yes. So like this, half of the
Okay, so to get
and then
you always do that second.
so this problem you can read it at 4 so it's really similar to this problem. So you put everything will change equals f of the final one. What's the final one? The 2 is the 5, so minus f of 2, yes.
Yeah. Yeah, and then that gives you set value.
Oh, okay, in the middle of the building. So termites.
No, you do, so you use this. You just plug in the 2 values for x. You use it first.
Flip this out.
Because
So average rate of change
so we're doing,
between the
we're not doing that first.
is f of the final one. What's the final one? 5, yes. Minus f
So
of
you
the
put
initial
5,
one.
just switch it
Over.
to get the 2, yeah.
Mhm. Over final one minus the initial one. So 5 Yes, very good. So what's this? This is f of 2. You can put down f of 2. Yeah, and you could this is f of 5. 26. Okay, now this problem is similar to this one. See, you're given the formula, right? And you're looking for the average rate of change on the input, right? 0, 2, 5. So you say average rate of change equals change of y over change of x equals f of the final point minus f of the initial point over final point minus here. F of the final point
The 2 and 5.
minus f of the over
Yeah.
final point minus.
Did you get negative 1?
Yeah.
Good.
Okay, good. So f of 2, you look at this formula and plug in x is 2. Yeah.
So is this correct?
2, 6.
From the Oh, okay. Can I have your So here, you mean this is x of 2.
Oh, I didn't know.
And then it's actually 2 points. So you use the difference of the y coordinate minus over the difference of the x.
Yeah.
Okay. So and then choose the function. You look at the denominator. If it's the same, then you can put it 1 minus 2. And then when you divide it by 3, it will become like the denominator.
And then that
So with this problem, there's change of y over change of x. So it's f of the final minus f of the initial 2 over the final point 5 minus.
it is 1/3 over 3.
Oh yeah.
So what that does is when you have a fraction over and then have an extra part, you put the negative. Yeah, well, it'd be negative 1/3. So that goes.
If this is then yeah, the one but equal to f of the final point. In your case, what was the final point? The 5, right? So it's f of 5 minus f of the initial point, which is 2. Yeah, over the final point. Oh, we work with number first. So you work with number first. So this is your left hand one. This is the left hand one, right? Oh.
No, I was.
Oh, okay. Oh, okay. So you use f of the final point. Yeah, you use f of the final point minus f of the initial point over final point minus.
So
You divide.
So in this case,
Divide by
it will be f of 5 minus f of 2 over 5 minus 2. Initial point and final point.
so it's basically.
That's fine. But 2 over 6 is 1 This is
Oh, yes, I have.
Yeah.
That was a lie.
It's just.
yeah.
I didn't know.
Yeah, interval. It's okay. Interval is from left hand point, right hand point. That's right. So this is all right. Yes. So y2 is 1/3. 3 And this is oh okay. This is not x1. This whole thing is y2, and this is sorry. The whole thing is y1, and this is x1. This whole thing is y2, and this is x2. Yes. And your slope is y2 minus y1 over x2. Okay, let's check our answers together. So we put average rates of change is bless you, change of y over change of x. And it's f of the what? Final point minus f of the initial point over in final point minus initial point. Is that okay, everybody? Mm-hmm. And f of 5, well, then you plug in x is 5 in the formula. So 2 over 5 plus 1, right? Minus f of 2, you plug in x is 2 in the formula. Right, everybody? And denominator. What is 5 minus 2? 3. Yay. Numerator. 2 over what? 6. 2 over 6 is 1/3. 1/3 minus what? 2/3 is negative 1/3 over 3 is negative 1 over 9. Remember when you divide it by a number, it's the same as multiply by its reciprocal. So you think of this as like A over B over C over D. Your D is like 1. Where do you put your C? In the denominator. Yes. Okay. Alright. So close. And part B. See, we haven't done part B yet. So now, I give you specific numbers for part A. Part B, how about in the interval from 0 to h? So part B, the average rate of change is gonna be same thing. F of the final point. What's the final point? H minus f of the initial point, which is it's 0. Yes. And then denominator. Sorry. Yeah, I know this font, the 0 looks like O. Yes. And what's your denominator? Final point is h minus initial point. Yes. Okay, f of h is, look at your formula, right? 2 over h plus 1. Yes. What's f of 0? 2 over 0 plus 1. What's h minus 0? H. Very good. Yeah, so now we work with a variable h. Let's try to simplify it. So 2 over h plus 1. What's the second term?
2 over 1 is 2, right? All over h. Alright, so let's see if we can simplify it. How can we simplify it? First of all, you want to combine them, right? So your common denominator is h plus 1. And then you have 2 minus the 2. You see the 2? You are actually multiplied by h plus 1 and divided by h plus 1, right? To get the common denominator. Yes, everybody, you want to combine these two terms, right? So we want to get the common denominator. And so here is 2. And then minus 2 times h plus 1. Right, everybody? And let's continue. So, okay, look at the top. 2 minus, when you distribute, what happens? Yes. Plus or minus?
Oh, minus, yeah.
Yes. Minus 2. Oh, do you see the 2 and 2 cancel? And so this is minus 2h over h plus 1. And over h. Remember we said a over b over c over d is a over b times d over c. So minus 2h and h plus 1. Tell me where this h goes. Numerator or denominator? Look, okay, look at this. Compare. This is A, right? This is B. And this is C. Yeah, and your C is like 1. Right? So therefore, you put the C in the denominator. So your H is actually here. Oh, what can you do? Can you see you can simplify the H? So we get minus 2 over H plus 1. So this is the answer. Yeah. Any questions? Okay. So please print out worksheet 1.4. Okay, on Wednesday we will talk about 1.4. Have a nice day. And who haven't finished our prerequisite review? Okay.
So I still have one more page, but I also left it at home. So.
Oh, okay. Yes, you can give it to me on Wednesday. Have a nice day.
Bye, guys.